Alright guys, so this is the second video. So this is what we went over on Tuesday. So not particularly looking at the graphs on this problem, but talking about some of the stuff that goes on in the equation. So they're telling us find the function where one of these equations has a amplitude of 3, period of 2 pi over 3, and a phase shift of pi over 4 to the right. And so that has to do with this equation here. And so here they did give me some info where amplitude is 3, period is 2 pi over b. So really what I want is the b value, because that's what goes into the equation. You can see here. And they told me the amplitude is 2 pi over 3. And I can see here, I mean, I don't want to go too much, but I see that this is, I mean, that these will cancel each other. So the b is actually just equal to 3 in this problem also. Again, I use this info. And here the phase shift is pi over 4 units to the right. So this is pi over 4 to the right, which means this is going to be a negative sign. Okay, so, and it tells me nothing about vertical shift, so we're not going to use that. So using this equation here, I know my a is 3, my b is also 3, x plus pi over 4, excuse me, negative pi over 4, right? That's what we said. And this is a correct equation, but if I look over here, this is not the form they have, so I'm going to go, excuse me, distribute this 3. So final answer here is, in the parentheses now, 3x, I keep messing this one up, minus 3 pi over 4, which corresponds to answer D. So a lot of y'all had problems with this question, so I'm going to go ahead and go over it in a separate video. I guess all I want you to know here, you should be able to tell first that this is the cosecant or the secant graph, which means it's not these two. And really the big takeaway on this one is the cosine graph starts up here on the top, and so I can see that I shifted the cosine graph, because normally the cosine graph would be right here, go down and then come back up, but I moved it this way to the tip of this point, and the cosine graph corresponds to the secant graph, so the answer here was B. So again, I'll go in a little bit more depth into one of these problems because it's a little weird, and so just look for the separate video on that. Okay, and next was linear and angular momentum. And again, guys, these conversions here, you need to know 1 revolution is 2 pi radians, 180 is pi radians. I did tell you that this equation was going to be given to you, and I thought it was, but it's not. So remember this equation, and the theta, the angle, has to be in radians. So make sure that you do that. So here, notice that this equation doesn't have radius, so really they're giving you extra info here, the 50-foot radius. But it makes 1.5 revolutions, so this is 1.5 revolutions per 1 minute, it says. And so I do have a time here, and I do have an angle, but again, this needs to be in radians, so all I'm going to do here is multiply it by 2 pi, because I know that 1 revolution equals 2 pi radians. So the end result is 3 pi radians per minute, which is what it's asking for, and that is answer C. Okay, and final problem for this set of questions is linear speed. So very similar to angular speed. Excuse me. Difference being this one is multiplied by a radius. Okay, so this one did not, this one did. And again, here the difference was they were asking for angular speed, and over here they are asking for linear speed. So remember, the angle has to be in radians, so I'm going to go ahead and convert this 120 degrees to radians. Okay, and when I multiply this out, guys, excuse me. Yeah. I can see that my answers are all decimals, so excuse me. So I would go ahead and multiply out 120 times pi divided by 180 instead of leaving it in terms of pi like I did in this other problem. Okay, so when I do that, this is going to equal 2.09, excuse me, radians. Okay, so I have my angle, I have my radius. Really the only thing I'm missing is time. So I'm going to go ahead and fill this in here. So all I'm missing is time, and I already know it's going to be in seconds. So this is what required a little bit of work on y'all. I don't know how familiar you are with like reading a regular clock, but they're telling me it's 120 degrees. So I'm seeing 120 degrees out of the 360 degrees because a clock is in a circle. I know it's not a very good one, but and I know that there are 60 seconds in a full circle. So I want to get the fraction of this 120 over 360, which I know is going to equal 20 seconds. So when I plug in the 20 over here, I find that my value, my linear speed, is 1.05 inches per second, which is answer A. So again, guys, this is the day 2 stuff. Okay. So look for the other videos.